Good morning. We'll start with this question number 13. We have a life insurance company issues a 25-year endowment assurance policy to a life age 40. Now see, whenever we have a lengthy sum, always before going through all the details, just give a quick look what we are trying to actually find. So prove that the monthly premium is approximately 240 given the following basis. So we have a lot of basis here. We have some expenses and stuff. We have even claim expenses. The insurance company calculates the surrender value equal to the gross retrospective policy value, assuming the same basis as in part 1. Calculate the surrender value at the end of the 20th policy year immediately before the premium then due. So we are talking about calculating the premium and calculating the gross prospective reserves. Okay. See, policy value, we talked about it yesterday. Capital V is for policy value or reserves. They are basically the same thing. Now we have a lot of initial fixed expense, initial variable expense, renewal fixed expense, and renewal variable expense and claim expenses. We have a lot of expenses here. Now, whenever they have given us a certain value, like here they are saying prove that the monthly premium is approximately 240. You can directly use that as a given value and just show that our expected present value is equal to expected present value of benefits plus expenses. So we can directly do that, use this 240. Okay, so that is what I would be doing. So here, first thing is I will be making the expected present value of premium. Okay. To calculate the premium, we have monthly premium 240. By default, we take premium in advance. Okay. We have select mortality, interest rate is 6%. Okay, so we will take 240 into 12, A due, payable 12 times. For age 40, we want select, and for 25 years. This is what our premium is going to be. Benefit. For benefit, we're talking about 100,000 is payable at maturity or at the end of the year of death. Okay, so 100,000. A, we are talking about endowment, select 40, 25. Now we want expenses. Expected present value of expenses. Expenses are the lengthy ones. So we'll take both the initials. Initial fixed expense is 1,000. Initial variable expense is 50% of the annual premium. So 1,000 plus 240 into 12 is becoming the annual premium 50%. So into 0.5. This becomes our initial expense. What about our renewal expense? Renewal fixed expense, we have 500 per annum inflating at 1.2308 per annum at the start of the second year and subsequent policy years. Okay, we'll talk about what's going on here. And the renewal variable expense is 5% of the second and the subsequent monthly premium. Okay, so we have second and subsequent monthly premium, and here we have start of the second year. So this fixed expense 500 per annum inflating at this value, this is going from second year, third year, fourth year, fifth year, and so on. This is annual value, whereas this renewal variable 5% of the second and subsequent monthly premium, this is monthly value. Okay. So first let's talk about the renewal fixed expense. Let me make a simple timeline. we are saying that the first premium, first renewal expense is going to be paid at the end of first year. So here is where our 500 is going to be paid. I'll just write it as 1. Okay, this is the first 500. Then next year we will have an increase. I'll write it as 1 plus b. Next year 1 plus b square, and so on. This goes on for. Okay, but we are going to write it in advance. We always write it as advance minus 1, right? This is what we write. So if we are supposed to write it like this, we would want this value to be at time 0, because advance starts from time 0. So this value here, whatever we are going to write here, must be value of time 0. So just by looking at this trend, look at this trend, right? We have 500, 500 into 1 plus b, 500 into 1 plus b whole square, and so on. The first value that we will be seeing here is going to be 500 divided by 1 plus b. 500 divided by 1 plus b, or for this timeline it's just going to be 1 by 1 plus b, right? So the first value is 500 divided by 1 plus b. That is what I will be using to write my expense. I'll say I'll have 500 divided by 1 plus b. Okay, or you can write it as 1.019238. Okay, we know what does this do. Okay, if I is equals to 6% and your b is equals to 1.92308%, then our I dash is going to be 4%. You don't even have to show this. You don't even have to show this. Okay, so our I dash is going to become 4%. So this becomes A due select 40 25 minus 1, and write that as I'll write it here at the rate of 4%. So we can write it. Okay. Then the variable expense, because we are talking about at the starting from the second and subsequent monthly premiums. Okay, so we'll have 5% into 240 into 12. Okay, we'll have A due select 40 25 payable 12 times minus 1 by 12. And finally we have claim expense of 2000 inflating at that same rate, so we'll get again 4%. Okay, so when we have payment at the end of the year of death, the assurance we will have 2000 by 1.012 1.0192308. We'll have A select 40 25, because it is a claim expense. Claim happens when a person when the death benefit is given or when survival benefit is given. So in both cases, either we are talking about maturity or we are talking about death. In both the cases we will see claim expense as well. So therefore at the rate of 4%. So this is how our expenses will be written. So you can see it's not a small equation. Here we can make a lot of different mistakes. So the complicated part in these chapters in 20 and 21 chapters, that is a premium and reserves, you will find is making the equation. After that it is very easy. Okay. After this, so much easier. You just have to take into account wherever we have not written at the rate of 4%, that is 6%. So our A due, select 40, 25, payable 12 times will be written as, I'll just write this little one more down. Let me just open the formula sheet so that we can refer it. So for whole life, because we have this 40, 25, that makes 65, we do have values in 65. Okay, have I written payable m times? Yes, payable m times. This is the formula that we can use directly, right? So ADO xn minus m minus 1 by 2m into 1 minus v raised to m n plus. So we'll write it as ADO select 40, 25 minus m minus 2m, that would be 11 by m minus 1 upon 2m, so 11 by 24, 1 minus v raised to 25, 25p select 40. You can calculate this separately, but I don't think it will be used anywhere else. Everywhere else we can get the values directly. This is the only term for which we will have to take the value calculating. But first again I will find v raised to 25, that would be 1.06 raised to minus 25 into L. So L65 will be this. And then we will have L select 40. Select 40 here. Okay, so this is what our v raised to 25, 25p select 40 would be. Now let's go to the AM92 4%, actually 6%. We are looking for the endowment values. So endowment, that is temporary annuity, we are looking for 65. This is n is equals to 60. We're looking for 65. This is the 65 one. Here age we want is 45. Oh, sorry, 40. Age 40. 13.290 minus 11 by 24, 1 minus, these values. This is 6%, this is 4%, this, all of these will be directly taken from the table book, right? So let's first write this. For benefits, we'll again looking for 6%, same thing. Okay, we want the endowment value 40 and whatever, this is the value. Select value, multiply 100,000, so it is 24774, directly 24774. And here expenses, first I'll calculate the initial expense separately. So I'll have 1000 plus 240 to 12 plus 0.5, sorry, into 0.5, 2440. This we'll calculate from the 4% table. Now we'll have to go to the 4% table. 4% ADU, select value for n is equal to 65. So n is equal to 65. Select 40, and then I want -1, so I'll directly write 14.887 plus, we want this 0.05 into 240 into 12 into, this is the annuity that we have, 12.927263 minus 1 by 12. Bracket close. Okay. And then plus 2000 divided by 1.0192308 into, this is again 4% table. So we want to show that our expected present value for premium must be equal to benefit plus expenses. Okay, so you can see it is slightly different, but we'll say it is approximately same. This is approximately same as expected present value of premium. Therefore, Therefore, premium will be equal to 240. Now, if you would have made all of these equations with P, then you will also get nearly value as 240. Okay. But this is easier in terms of calculation. Okay. You could have made everything in terms of P, then equate them and find the premium, but this becomes easier in terms of calculation. Because P will not be only here, but it will also be here and here. Okay. So premium we said is 240. We'll take that for our later on calculations. For the second part, they are asking us to calculate the gross retrospective reserves. Right. They're saying to calculate the gross retrospective reserves at time 20. That is what we want to calculate immediately before the premium then due. Okay. So when we talk about gross retrospective reserve, that means we are talking about our past values. In past values, we will be taking our initial expenses. Okay, the reason I wrote initial expense value separately because I can directly write this rather than writing this. Okay, that is why I've written initial expense value separately here. Okay. So when we say gross retrospective reserve, so 20V, that is what we are calculating here. For first 20 years, what will be our calculations? That is what we want to show. So because it is gross, we'll say it is premium minus benefit minus expenses. Okay. So the premium will have 240 into 12 A due going for only 20 years. So 40, 20 payable 12 times. This is our premium minus benefit. Benefit in retrospective, always remember only death benefit was paid for those 20 years because maturity payment would have been done at time 25, not on anywhere between 0 to 20. Okay. So we will have just the term values, not the endowment values. So we'll have 100,000 A select 40 dash 20. Okay. A select 40 dash 20. Then expenses. Expenses initial 2440. What about rest of the expenses? Yes, this expense will also be seen, and again we will have -1 because we are talking about not including the first year. This expense will also be seen, and we will have -1 by 12 again because again not taking into account the first month, and this will be our claim expense, exactly same in terms of how it is. Okay. So I'll write it in bracket because we'll have a lot of terms here. So plus 500 by 1.0192308. In bracket we'll have A due select 40 going for only 20 years payable 12 times -1. Oh, sorry, not payable 12 times. This is at the rate of 4% and -1. The next expense, that is 0.0. I'll just calculate that rather than writing it again that way. 0.05 into 240 into 12. 144. 144 A due payable 12 times. Select 40 going only for 20 years. Minus 1 by 12. And plus 2000 on 1.0192308. A select 40 20. This will be dash, because again the payment would be given, the claim would happen only at death because there is no maturity till this time at the rate of 4%. And then we will have to divide this by v raised to 20 20p select 40. Now we'll be using this for at least for this term. I don't think for any other term, so we'll have to calculate this separately anyways. So now we cannot use any of the above calculations because everything is now 20 20 20 20 instead of 25. But 40 plus 20 we have 60, so we have some values. This 60, this is for 4%. Okay, and these again we'll be using endowment tables to find these, again 6% and 4%. Okay, so for 4% I have written capital D so that I don't get confused between 4% and 6%. First I'll calculate v raised to 20 20p select 40. L60 select 40. Let's go to 6%. Endowment table. We want select value. In this we want n is equals to 60 minus x. Okay, so we want age 40, 12 minus 11 by 24 into 1 minus, so 11.6765353. Now I will use the endowment minus pure endowment to get term 0.32076. This is the term value. And this will be calculated at 4%. 4%, n is equals to 60 minus x. Endowment value is this 0.4423 minus capital D values, D60 by D select 40. So we have this. We don't have this, but we can directly take this from the table book. This. Okay. So let's make the equation. Bracket 240 12 into 6. Okay, these are not plus, these are expenses. We will be subtracting all the expenses. Minus, just change them. Expenses we will be subtracting. This we'll take it directly from the table book. We want at 4%. Sixty value 13.93, target as 12.93. Minus 144, 676. Sometimes very lengthy equations are not possible for us to type in a physical calculator. At that time, you just have to calculate all of this in parts. And then divide by v raised to 20, 20p 40. That was 0.293861. So the reserve is 69484.135. So you can see questions do take a long time to solve when we have very complicated equations. You can imagine then typing it in Word. So it does take a long time. You have to be, that is why faster typing, so that we don't waste a lot of time just because we are slow at typing. Okay. There are so many places we could have make mistakes. Select ultimate mortality, we can make mistake in that. 4%, 6%, we can make mistake in that. Writing equations, we can make mistake in that. Calculations, we can make mistake in that, right? So there are so many places we could have made mistake. We could have made mistake while calculating the premium. We could have made mistake while calculating the reserves. And you know that, let's say they asked us to calculate the premium. Okay, find the premium. Then we would not have even known that if this was correct or not, right? If we were supposed to find the premium, P was unknown, so we would have not known whether this is correct or not. We don't have any way of checking whether we did everything correctly or not. And then if premium is wrong, then reserves is also wrong, because we are using premium here for so many different things. Okay, and you may get some marks for writing the formula correct, but because the premium is wrong, all of this becomes wrong. We are wasting a lot of time where we are not getting marks. So accuracy is very important in CM1, because it takes a long time for us to solve questions, big questions, and if we are not getting marks for it, then what is the point of it, right? So accuracy matters a lot. Now let's talk about the next chapter, that is mortality profit. We will directly do chapter 24, not we'll be doing 22 and 23 later on. Yes. So chapter 24 is mortality profit. Now, usually we are finding our premiums by equating our expected present value of premium to expected present value of benefit and expected present value of expenses. So we are not calculating any profit. We are not saying that we have taken any profit into account, right? So where do we earn profit? Okay. So we will be earning three types of profit. The first is interest profit. We are saying that we will be earning rate of interest of 4% or 6% on whatever we have. Okay, so let's say we calculated everything according to 4%, but we actually earned 5% in a particular year. Okay, we earned an interest of 5%. So that extra 1% is our profit because all the calculations were done according to 4%. So that is where our profit comes from. One of the ways, interest profit. Then we might have expense profit. We expected that each year there will be a renewal expense of 10 rupees per policy. Okay. But in a particular year, we only required 8 rupees. Okay. So that becomes a profit. We have now profit of 2. Because we expected that we will have an expense of 10, but due to some reason in a particular year we had an expense of only 8. So that is a profit. Expense profit. And the third is mortality profit. Okay. So mortality profit, whatever expectation of mortality we had. Okay, so we were calculating all the mortalities according to probabilities, and we say that let's say we sold the policy to 10,000 people. Out of that, we were expecting that this year 2.457 people will die because we are multiplying probability. Okay, and obviously 2.457 people will not die in a particular year. It's not possible, right? So either it will be 2 or it will be 3, or it can be actually 1, or it can be 5, or it can be 20. Chances of that happening, that we have a very large value, would be very low. Probability of that happening will be very low, but that does not mean it will not happen. It might still happen. So we were expecting 2.457, but we got, let's say, 5. Then what happens? Okay. So depending on the policy type, okay, it might be advantageous or it might be not advantageous to us as in terms of profit if more number of deaths occur or less number of deaths occur. It depends, okay, type of policy. Rather, if we are talking about whole life, term, or endowment, in all of these, if less death occurs, we'll have profit. Let less death than expected occurs, then we will have profit. If we are talking about pure endowment, or we are talking about some annuity style policy that we saw yesterday, remember, when we were calculating the probability style question. In this, if more deaths occur, then we will have profit. So depending on what is happening, we are saying we expected a certain number of deaths, but in actuality we got a certain different kind of number of deaths. Okay. So in that case, what is happening here is we are having either profit or we are having loss. So we can have either mortality profit or we can have mortality loss. That is what we are studying in this particular chapter. We'll see later on in using some examples how we could calculate interest profit and expense profit. But the main reason for this chapter is mortality profit. Here we are going to use a certain formulas. I will just write down the formulas and then we will see what they are. Okay. This literally ends the chapter here. We are literally going to calculate only these four things whenever we are talking about mortality profit. Okay. There is one thing I forgot to talk about in chapter 21. I will be talking about that after we are done with this. Okay. First, we will be writing what does this mean, DSAR. DSAR means death strain at risk. S we know is sum assured. Payable at the end of the year. Okay. T plus 1V would be the reserves kept at the end of the year. Okay. Then R is annuity amount payable at the end of the year. EDS is called expected death strain. Here NA is number of people, or we can say policy holder active at the beginning of the year Qx plus T minus 1, Qx plus T minus 1 would be probability of death during the year, probability of death during the year, ADS would be actual death strain, ND is actual number of deaths during the year, okay, and MP is nothing but mortality profit. Okay, write this down. I'll be back in 1 minute. Okay, so DSAR, that is a death strain at risk. What is that? So we are saying for the company, what is the strain that the company takes if there is a death? Okay, so at a particular year, so all of this calculation is done for one single year, okay, because we will be calculating profit every single year. So we'll say how much strain does the company incur if a death occurs. So we'll say that the company has to pay the sum assured, the death benefit that was promised. Then the company does not have to keep reserve for the next year, right? Because the person is not active anymore, we will keep reserve only for the people who are active. And then by any chance, if we were talking about any annuity that was supposed to be given at the end of the year, we are not going to pay that. So we are assuming, see, the death is occurring between time t minus 1 and time t. Okay, so you are calculating death strain at risk for this year. This is year t. Okay, so we are saying t plus 1. See, the reason we are writing t plus 1v, we are saying we don't have to keep reserve for the next year, but we are actually talking about beginning of the next year. That would be time t. In actuality, we should write it as tv, but this is what the book writes. That is why I write it the same way. Okay, so this reserve is basically at the beginning of the next year or at the end of this particular year. So therefore, I am not writing exactly what t is anywhere. I am not writing what t is. We'll go by the logic. We are saying if we are calculating mortality profit for this year, we are talking about the reserve at the end of this year. That is this. Okay, at the end of this year. So if the person dies within that year, here death occurs, we know at the end of the year we have to pay the sum assured. We don't have to keep the reserve for the next year, so I can use that money to I don't have to keep this much value, so I can use that money to pay off the death benefit. And if by chance there was supposed to be an annuity that is supposed to be paid at time t, we don't have to pay that. So this becomes the death strain at risk. This is the extra amount that we'll have to pay if a death occurs. Okay, so if a death occurs, this is the extra amount that we will have to pay at the end of the year. Then how many deaths were we expecting in this year? So we were expecting total number of people active at the beginning of the year. At the beginning of the year, these many people were active. Out of them, this much, this is nothing but the probability of deaths in this particular year. So in this particular year, we are assuming this is the probability of deaths that we would see. So this becomes the total number of deaths that we expect in this particular year, because we don't know what would happen. While we did all our calculations of premium and reserves and everything, we don't know how many actual number of deaths would occur in a particular year. So this was our expectation. This is the expectation of how much strain we will see in a particular year at the end of that year. This becomes the expected death strain. Then actually we are saying these many number of deaths occurred in this particular year. Now that year has passed, we know how much payment we did. We are calculating whether we earned profit or whether we earned losses. Okay, so this is the actual number of deaths. Okay, actual number of deaths is ND, and we'll multiply DSAR to it to get the actual death strain. And we'll say our mortality profit is expected death strain minus actual death strain, because we prepared for the expected death strain. We prepared for the expected death strain. So if expected death strain is more than the actual death strain, then the money that we have is nothing but our profit. If it is less, then it is loss. We had to pay a little bit more out of our own pockets. Is that clear? Literally, we have to calculate these four things after calculating reserves, of course. And that is all we have to do for mortality profit. Any problem here? We'll be doing some of this, but before we do that, I just want to tell you the small thing that I forgot to talk about of chapter 21. Of chapter 21, we have something called as recursive relationship. Okay, recursive relationship. This is a way of finding reserves if we already know a reserve of either previous year or the next year. Okay, using recursive relationship, we can find reserves for this whatever year we are talking about. So let's assume that we know the reserves at time t, and we want to find reserves at time t plus 1. Okay, now there is a formula for recursive relationship, but it's more confusing than useful. So what I always say is, let's figure out how does this recursive relationship work, and every single time we'll make that relationship. So recursive relationship says whatever happens at the beginning of the year into 1 plus I should be equal to whatever happens at the end of the year, because these are just cash flows. Traditionally, when a policy starts, I am not going to be keeping on putting money from my pocket in the what do we say, policy. That is the dream, that once the project starts, once a policy starts, the company does not have to do anything. The cash flow of the that is generated by the policy is going to be enough to sustain that policy. All the premiums that is supposed to be collected, that would be compensating for whatever is happening. So we'll say whatever cash flow occurs at the beginning of the year into the accumulation for that year should be equal to whatever is happening, whatever cash flows at the end of the year. So now what are they? We'll say at the beginning of the year, see what happens is we'll say the reserves are kept at the end of each year and then they are released at the beginning of each year for the purposes of using in that particular. That is just conceptual. It does not actually happen that way, but we'll say that at the beginning of each year we will be collecting premiums. So collect the premium and we will have recursive expenses. So I'm subtracting recursive expenses from that premium. Then we are also going to say that we will have the reserves that were kept in the previous year. Okay. So TV, we have reserves that was kept in the previous year. These are all the cash flows that happen at the beginning of the year. At the end of the year, what happens? At the end of the year, if a person dies, then we will be paying the sum assured value. And if a person survives, then we'll keep reserves for that particular person, right? So we'll say we will have S plus F if you want to take the terminal expense as well. So S plus F. And for probability of people dying in this particular year, so I'll say it is going to be Q x plus t minus 1. This is the probability, actually x plus t. And for anybody who survives, we will have to keep reserves for the next year. So we'll say it is t plus 1 v p x plus t. Now we will be equating this. We'll say premium minus expenses upon plus TV. These are our incomes. Income accumulated for 1 year, 1 plus I, should give us, these are all our expenses. We have to keep reserves. So we have to put the money in some other account. Then, what do we say? We have to give sum assured and expenses. So these are all expenses. So S plus F Q x plus T plus T plus 1B Px plus T. Now you can rearrange however you want. If you want to find this, you can rearrange it. If you want to find this, you can rearrange it to get your equation. But this is what a recursive relationship is. We can use the understanding of the cash flows and make the equation very easily. Cash flows, or you can say the income happening at the beginning of the year into 1 plus I is equal to the expenses that we'll see at the end of the year. Okay, this is called as recursive relationship. As I said, rather than remembering this as a formula, I prefer to make this timeline quickly and figure out what are the expenses and what are the income in that particular year. So if you are confused, what is happening at the beginning of the year? We are collecting premium, we are having recursive expenses, and we will say that the reserves are released for that particular year. So what we are saying is every year at the end of the year, we are keeping reserve for anybody who is alive in a bank account. So we have a bank account that is just for the reserves. Okay. And we are saying here that that bank account is also earning the same rate of interest. Okay. So therefore, this much reserve was kept per person at the, in the previous year. Whoever survived for that, this much reserve was kept. All of this is going to earn interest for 1 year. This is the interest that would be earning for 1 year. Okay. And then out of this, what we are going to do is we are going to pay off any death benefits plus claim expenses. Okay, so the death benefits paid is this much for anybody who did not survive that year, and reserves will be kept for anybody who survives that year, so that next year again we can use that reserves. Okay, so we are assuming we are taking all of this out at the beginning of the year, or let's say these are our income at the beginning of the year, these are our expenses at the end of the year. Okay, let's solve a sum of recursive relationship first, and then we will solve DSAR and stuff. So see this question, this is chapter 21, page 32. We have chapter 21, page 32. Consider a 25-year regular premium endowment assurance policy with a sum assured of 75,000 payable on maturity or at the end of the year of earlier death. Taken out by a 45-year-old, expenses are 75% of the first premium and 5% of each subsequent premium plus an initial expense of 250. Given a gross annual premium of this much and a gross premium reserve at the end of 10 years. So they do call it as premium reserves. Okay. So gross reserve, I always use the term gross reserve, but the technical term is gross premium reserve, net premium reserve. Okay, that is the name. So gross premium reserve at the end of the 10 years is 20,898. Calculate the gross premium reserve at the end of the 11th year. So we have value for the previous year. We are talking about what is the reserve that we will have for this year. So they are saying AM92 select mortality and 4% per annum interest. Now just for the recursive relationship, we are talking about after 10 years. After 10 years, there is no use of our select mortality here, right? After 10 years, select mortality is of no use. So this is of no use, select mortality no use. Similarly, the first premium as well as the initial expense is of no use. This information is just there to confuse us. Expense of the first premium and the initial expense is of no use because that would happen at time 0. So at time 10, what happens? Time 11, what happens? So we are saying at the beginning of the 11th year, we will be earning premium. I'll just write as P minus 5% of each subsequent premium. That is what we will be subtracting. So I can just say 0.95 premium is what we will be getting at the beginning of the year, plus the reserves that was kept at the end of the previous year, that is this 20,898. Okay. We will use that to pay off what? Sum assured for anybody who dies in that particular year. So Q, 45 was the initial age, 10 years. So it will be 55. Q55. And then we will keep reserve for whoever is alive. P55. If the person survives this year, then we will keep reserve for that person. Again, 0.95. Premium is 2132. Or I'll just make the equation. 0.95 P plus 10V into 1 plus I, that is 1.04, will be equal to, sum assured was 75,000, Q55 plus 11V P55. Find these values from AM92. All the other values are given. You have to find just 11V. Find these values and tell me what would be our 11V. I'll be back in just 2 minutes. So what was the answer? This seems to be the answer. Okay. So rather than remembering the formula like this, that will change every single time, I want you to remember the relationship. Okay. Okay. Let's solve a sum of mortality profit. Chapter 24. So let's see question number 24.1. We have on 1st January 2009, the life insurance company sold a number of 10-year pure endowment policies, each with a benefit amount of 40,000 to life then aged 30. Level premiums are payable annually in advance. Calculate the annual premium. So let's calculate the annual premium first. So you can directly make the equation when the expenses and stuff are not much, but this is what usually I do. Expected present value of premium. So level premium in advance, ADU, for what? 10-year endowment policy. You can see mortality is AM92 select. So I will have select 30 for 10 years. And expected present value of benefit would be 40,000. A select 30 10. Pure endowment. So this, or you can directly say it is V raised to 10 10p select 30, pure endowment. Okay, so let's calculate the annual premium. We are talking about 4%, so this would be D40 by D select 30. Use that. D40 D select 30. %, ADU select 30. So into ADU ultimate 40. Ultimate 40. Okay. So P will be how much? This much divided by 8.4142. So premium turns out to be 3189.71. And they are saying on 1st January 2010, 1st January 2010, that is 1 year after the policy had started. Okay, there were there were 50 of these policies still in force. So that is NA. At the beginning of the year, how many number of policies still in force? During 2010, one policyholder dies, so that is the ND. Number of deaths, 1. Calculate the company's mortality profit for 2010. So to calculate the mortality profit, we have to first calculate the reserve that is supposed to be kept at the end of this year. So see, first year was 2009, second year is 2010. Okay, so we are talking about at the end of the second year. So 2V is what we will be calculating. You can use prospective, you can use retrospective. Okay. Here I will show you both using prospective as well as using retrospective. What happens? So if I'm using prospective, 2 years select goes away and I will have 40,000 V raised to 8, 8P select, no select because now the age is 32, so age 32, and then minus premium into ADU 32 for 8 years. This is our prospective way. What is the retrospective way? Whatever happened in the past. Now, because this is an endowment, pure endowment payment, there is no payment of benefit before this. There is no payment of benefit before this. So literally, if we calculate using retrospective, we have only the premium payment. So premium due select 30 for 2 years. And that can be written very easily as 1 plus, if the person survives for 1 year, then the payment would be given. So V and then P select 30. So this is so much easier to calculate than this, right? Of course, we'll have to divide this by V raised to 2, 2P select 30, and divide this by also V raised to 2, 2P select 30, because we are talking about retrospective calculation. But you can see this is so much easier. Retrospective calculation here is so much easier than the prospective calculation. Just because we had only 2 payments. Okay. So I think we were talking about 4%, or we were talking about 4%. Yes, 4%. So we can calculate this from D table. D table 30 and 32. So first ultimate 32. Select 30. This is V raised to 2, 2P select 30. Then for this, we just need the P select 30, or I will be using 1 minus Q select 30 here. So premium was how much? Premium was 3189.71 into, in bracket, we'll have 1 plus 1.04 raised to minus 1 into this P select 30. P select 30, I will write it as 1 minus Q select 30. Q select 30. Q select 30. Q select 30 would be this 0.000476, bracket close, another bracket close, and we will divide by this. So divide by answer. So we'll get reserves as 6772.787. This is the reserves that we will be keeping at time 2. After this, the calculation is so much easier. We'll calculate first DSAR, death strain at risk. Death strain at risk would be sum assured, that is death benefit given at the end of the second year, minus 2V, this is the reserve that we will be keeping, and there is no annuity, plus R, there is no R here. Okay, no annuity is given at the end of the second year, and also no death benefit is given. because we have only pure endowment value, so no death benefit is given. So this is literally minus 6772.787. This becomes our DSAR, death strain at risk. What was the expected death strain? Expected death strain would be NA into Q, probability of dying in the first year. So probability of dying in the second year. So it would be Q select 30 plus 1. This is what we want, into DSAR. Okay. So NA we know is 50. We'll calculate this from the Q tables. So we are already at Q tables. 30 plus 1. Select 30 plus 1. So select 30 plus 1 is 0.000569 into DSAR, so into minus 6772.787, so minus 192.685 is the expected death strain. What is the actual death strain? We are saying one person died within that year, so ND into DSAR. So actual death strain is 6772.787, and mortality profit is expected death strain minus actual death strain. This is the mortality profit that the company earned. Because what happened here was we were expecting less than one death. Okay, because out of 50 people, Q 30 plus 1 was a very small value, right? Q 30 plus 1 was 0.000569. So if I just say 50 into 0.000569, you can see 0.028. So we were expecting 0.0828 deaths. So you know, definitely less than 1. Of course, that cannot happen because total number of people were 50. So either we would have had 0 deaths, or we would have had 1 death or 2 death or 5 death or whatever. And in such policy, if we talked about that annuity policy or pure endowment policy, if we experience more number of deaths than expected, then we will have mortality profit. Because clearly what happens is more number of people died before the payment and there were no payment here. So at the end of n years, whatever n years we are talking about, the number of people alive would be less than expected. Okay, because more number of people died within that term. So then we will have to pay less pure endowment sum assured at time n. So therefore we have profit. But this is profit at the end of the second year. This is mortality profit at the end of the second year. Okay. So let's end our class here and we'll continue this tomorrow. Okay. So chapter 24 is simple. That is all we have to do. Calculate DSAR, expected death strain, actual death strain, and then mortality profit. That's it. There's no other calculation. So tomorrow we will be starting chapter 25. So it might seem like we are running very fast, but the conceptual things are already done. The practice part is what you will have to do yourself. So you will definitely have a lot of doubts. As you keep on solving, bring those doubts and we'll clear them out, right? So for this part, especially from chapter 15 or actually chapter 20 to chapter 28, we require a lot of practice. Every day you should at least give 2 to 3 hours to practicing. Only then you will be able to comfortably say that you have enough practice done by the time of the examination. Okay, or at least by the time we will be completing all our course. After that you will have time to practice again. Okay, so let's end our class here and we'll meet tomorrow 6 p.m. Okay,
Thank you, sir.
welcome. Okay, bye.